Okay, so DigiCert, you have established World Quantum Readiness Day. I think it's taking place early September. So just be good to understand sort of why you came up with the idea, why the need for such a day to start
Sure,
with.
yeah. This is the first World Quantum Readiness Day taking place on September 26th. And the purpose of this specific day is a day of awareness. For the past 7 years, National Institute of Standard of Technology has gone through the process of choosing post-quantum crypto algorithms, which are a set of algorithms that are protected against the threat of quantum computers. Now, what we have realized in the past 7 years is that folks aren't really aware of how deep and how wide the threat of quantum computers are. We established the World Quantum Readiness Day here at DigiCert. We are bringing multiple different experts, both quantum computer experts as well as cryptographers, where they are capable of telling everybody the end-to-end story, what the problem is, what the solution is, and why now is the right time to begin transitioning to quantum safe algorithms.
Okay, and in terms of quantum computing, sort of at the sort of high level, I guess it's a bit like AI in that a lot of people talked about it, a lot of hype. Clearly, AI is beginning to deliver, etc. But there are people are finding out sort of opportunity challenges. I guess quantum computing is the same. So it'd just be good to understand, I suppose, what the pros and cons are. Particularly, I suppose, the benefits, if you can outline them first, and then maybe we'll look at the downsides, which you alluded to there.
Certainly. For decades, we have been using computation based on what we call classical computers. These are your laptops, your servers that you're dealing with, the cell phones that we have, and the processors on these compute units are capable of only processing zeros and ones at a time. So it's either a zero or one. Now, quantum computers are utilizing qubits, and qubits are taking advantage of the phenomena of quantum mechanics, specifically entanglement and superpositioning. Consider that you're capable of solving multiple problems in a much faster period of time because the capabilities that quantum computers are bringing is completely different than capabilities that classical computers bring. And this comes at an advantage and obviously disadvantage. The advantage is that, for example, doing weather forecast modeling, doing cancer cell modeling, stock markets, large data analysis, and so forth, could happen on a much faster pace on a quantum computer versus a classical computer. Now, these are the pros, and the cons, unfortunately, is the impact that a quantum computer, and I shall say a stable and large enough quantum computer will have on existing encryption algorithms that we use. For about 40 or 50 years, we all believe that the encryption algorithms that we are utilizing is not going to be broken for thousands or millions of years. And that's because the compute powers of classical computers wouldn't be where when they're capable of solving the factorization problem, which is the basis on most of our encryption algorithms. Now, quantum computers are going to completely change the face of this equation. Instead of taking thousands or hundreds of years, a stable and large enough quantum computer is capable of solving the factorization problem in a matter of seconds, maybe hours, maximum, maybe weeks, but not thousands or millions of years.
Okay, and what's the time frame? Because as I understand it, I mean, people are already sort of produced fairly basic quantum computers, as I understand it, but they're not actually capable of performance-wise of anything more than current, as you say, classical high-performance computers. So, at what stage does the quantum computer start, overtaking what is possible with, as you say, classical computing, and the problem becomes, acute, if you like?
Yeah, I mean, contrary to the public belief, actually, we do have powerful quantum computers. But when you're saying powerful quantum computers, it really, the question has to be asked, which is, what type of problems are you throwing at these quantum computers to solve? For example, the latest numbers that we have a 1,000 qubit quantum computer. IBM has 400 plus quantum computer. These are all good and large enough quantum computers where they're capable of solving certain problems, again, such as that mRNA, weather modeling and forecasting and so forth. That being said, these large quantum computers in 1,000 qubits aren't big enough or stable enough to break the encryption algorithms. A matter of fact, to those who are interested, very similar to AWS, compute units that they can go ahead and sign up for. They can sign up for quantum computers and do some computations on. Obviously requires a little bit more of a skill set and so forth, but these are widely available today, and the public domain can go ahead and utilize these quantum computers.
Okay, and as I understand it, because I've done a bit of work in the semiconductor industry, the sort of million qubits is the sort of holy grail for now, and people are using different materials, etc., to try and get there. So, are we talking, couple of years, or are we talking like a decade, just so people can get some understanding of when, as I say, the sort of the security problem might materialize?
Yeah, so it's certainly million qubits is way far away. Right now, we are dealing with hundreds. We have passed 1,000 qubits. Unfortunately, in some cases, specific in security, fortunately, quantum computers do not follow Moore's law. Since you mentioned semiconductors, Moore's law basically says every 16 to 18 months, the number of transistors will double. That does not apply to the case of quantum computers. So basically, your qubits doesn't double every so frequently. So a million qubits is far away. We just have passed 1,000 qubits. And I think the next big one will be creating a stabilization above 1,000 qubits. And in addition to that, very similar to how we have distributed computing, how organization will be able to actually connect multiple different quantum computers together, 500 qubits here, 1,000 qubits somewhere else, and be able to distribute this computation between these multiple different qubits.
Okay, but I guess the important thing, and hence the idea for the World Quantum Readiness Day, is that organizations need to be quantum ready to understand what's come. And I guess what is the day trying to do, or what do people need to do, to start preparing for this world?
Yeah, look, for the past almost 40 or 50 years, we have been utilizing these encryption algorithms such as RSA and ECC in our environment. This actually is so seamless that both you and I are utilizing it through this session. If you are going to any website, matter of fact, you're utilizing it, or any application on your phone, most likely utilizes this encryption algorithms. The point here is that these algorithms are so widely distributed that any type of threat, such as the quantum threat that we are dealing with right now, it will not only impact one organization, it will impact every single organization across the planet. This will be impacted as far as a patient in a hospital who's dealing with a medical device that has this encryption algorithm on, all the way to a satellite in the outer orbit, and obviously to children in schools when they're dealing with their tablets to do their homework. Now, when it comes to an organization, in order to be prepared and take the proper posture against the threat of quantum computers, the first order of business is visibility. They need to really understand where these semi-broken encryption algorithms are in their environment, create an inventory of those. And then the second order will be to automate the replacement on these cryptographic libraries automatically, where they could potentially move from the classical algorithms to PQC algorithms, and keep that sense of crypto agility in mind as they're moving forward with their strategy of deploying encryption algorithms.
Okay, and I believe in terms of some of the work that's been done already, there are post-quantum cryptography standards being developed. What can you give us just an update as to where those are at? Are they still in development, or are there some already there? Just your thoughts as to where the standards are.
Yeah, so NEST started a process about 7 years ago where they began asking for submissions of set of algorithms that are protected against both classical computer and quantum computers. We often refer to these as post-quantum crypto or quantum safe algorithms. The process took 7 years. There were multiple different submissions. Some of them merged together, some of them dropped from the process. But where we are standing today in summer of 2024 is we have 3 signature algorithms that are going to get their final specifications most likely prior to end of this year. This year, we have dilithium, we have Sphinx Plus, and Falcon. Those are 3 PQC signatures. And we also have one key encapsulation mechanism by the name of Crystal Kyber that is going to be standardized pretty soon. So the process of 7 years has been trimmed down to 3 signature algorithms and 1 KEM that most likely are going to be released to the public prior to the end of this year.
Okay, and in terms of how and where those will be used, I mean, is it going to be the companies offering cybersecurity solutions that are going to have to take these on board, and therefore as users, as long as we know those folks have got them, we're safe? Or do end users need to sort of sit up and take notice themselves? Just, can you explain that, please?
Yeah, so it's actually a very complex transition. Why is this complex? For multiple different reasons. Number one, to my previous point, if you really don't have visibility into your environment, you really can't figure it out what you're replacing. In other words, you need to have that high visibility of what is going to be broken, and replace that first. But even if you move forward with that replacement, you have the problem of backward compatibility. You do have your legacy clients who only understand the legacy algorithms. You do have your new servers where they're only speaking the new post-quantum crypto algorithms. And now you have this miscommunication in between. Now, for organizations where they're going to deal with these problems, they most likely should reach out to companies such as DigiCert or other providers where, one, they do have the proper tools and solutions that is capable of providing that level of visibility and automation. Two, they have the skill sets that really does understand the performance impact of deploying these post-quantum crypto algorithms. And number three, they have done this in the past. We are dealing with manufacturers, for example. These are embedded and IoT device manufacturers. We are dealing with financial institutions. And the point is that we do understand these use cases. Now, if an end user just decides to go ahead and deploy these new set of algorithms, they most likely can, but the success rate of that is often very, very low.
Okay, and in terms of alongside the development of the standards, are there any other sort of initiatives, whether individual companies such as yourselves are pursuing, or industry-wide groups that are looking to address, as you say, this post-quantum cryptography world that we're headed towards?
Absolutely, yeah. We are highly involved in dozen different standard groups, anything from X9 from the financial sector all the way to ETSI, which is the European Telecommunication Standard. Obviously, NEST, CAP Forum, which is the CA browser forum. The point is that introducing a new post-quantum crypto algorithm, a matter of fact, any algorithm has impact in multiple different standard groups, either being protocols or applications, but also different use cases required to really understand what type of performance these algorithms are bringing in. Our job at DigiCert as one of the providers of digital trust is to make sure that we are heavily involved in these standard groups from day zero, making sure that we are capable of helping to write these new standards where the impact on customer is not downtime or additional cost, instead is more security and a more reliable path forward.
And in terms of your role helping customers, I mean, if someone knocks on the door and says, we're aware of this problem, can you help? Are you able to give sort of a consulting role, as well as presumably, obviously, you have solutions, commercial solutions, but are you happy to sort of guide them along that whole path, or do they need to go somewhere else through a consultancy first and then come to you once they know what they need to do? Just where it is you fit in exactly.
Yeah, certainly. So we announced our Trusted Quantum Advisor program, which is our consulting program for quantum safe migration about a year ago. And what we are doing is we are sending our experts either on-site or virtually, where we are going through multiple different buckets. Bucket number one is education. Every team really has to understand what these post-quantum crypto algorithms are, what's the difference between the classical ones. Then we will move forward to doing POCs. But most importantly, we are helping these teams to come up with a strategy that could align with their specific goals within their organizations. And finally is the implementation of the solution. So yes, we do have a consulting offering that we offer to multiple different customers, and we tailor those consulting solution based on the environment that the customer has.
Okay, and maybe sort of if you can put this in perspective, because clearly the security industry sort of moves on, somebody develops something like I mentioned at the top of the thing, clearly AI is having impact on cybersecurity, again, for good or bad. And I say people deal with it. With quantum computing and the fallout from that, is this, if you like, just another security problem, or is it of a sort of order of magnitude that we've kind of not seen for a long time, if ever? So is it a huge, great sort of upheaval that we'll be seeing, or is it sort of, as I say, just another sort of step in the cybersecurity evolution?
No, the impact of quantum computers against cryptography is orders and magnitudes bigger than anything else that we have dealt with in the past. And the reason for that is that cryptography now is the foundation of vast majority of applications that we are dealing with. I say vast majority of applications because regulations are very big on cryptography. If you are in the banking industry, you must deploy some type of cryptography. If you are in patient data information, insurance, you must deploy some type of cryptography. Obviously, military applications and communications are also in the same bucket. Now, what we have seen with cryptography is that it gets deployed so seamlessly that is part of everything. And imagine that this foundation overnight will be broken. Now, again, irrelevant of trying to go to your favorite streaming website or social media or going to your bank, they all are using the same common denominator, which is this broken encryption algorithms in a sense, once we have a stable and large enough quantum computer. So yes, the impact is catastrophic once we get to the Q day.
Okay, and perhaps just in finishing, one or two bits of advice for organizations who want to start putting together a strategy, I guess, both for the opportunities of quantum computing, but particularly as we've discussed, the challenges. What does, I suppose, a plan look? I think you've obviously referenced certain things, but perhaps if you can just summarize what a good sort of strategy is in terms of addressing the problem on the horizon, shall we say?
Yeah, absolutely. Look, I know this sounds ironic, but the recommendation is not to move to a post-quantum crypto algorithms directly. Instead, the recommendation that we make to vast majority of our customers is to implement crypto agility. Crypto agility is a set of tools and abilities that enables you to be able to dynamically switch from one broken algorithm to another algorithm seamlessly with minimizing the downtime. Now, this by itself doesn't mean that once you move to a post-quantum crypto algorithm, the job is done. Crypto agility means that you do have capabilities to switch to the first post-quantum crypto algorithm, later to the second one if the first one is broken, and so forth. So recommendation for your audience here is to follow the three elements that we often refer to as our trust lifecycle manager solution. Number one, gain visibility into your environment. Do discovery, create those catalogs, inventories of all of the cryptographic assets under one umbrella. Number two, create an automation solution. Make sure that you really don't need to call a sysadmin to replace a cryptographic algorithm. You can automatically do these. And number three is to come up with policies and management roles that enables you to execute set of rules depending on the criteria that you have set in case that you need to replace these algorithms at a moment's notice.
Okay, been a fascinating conversation into what's a really interesting topic, and clearly is going to be an issue into the future. But at least for now, Avesta, I really appreciate talking to you. Maybe we can have a chat second half of the year or whatever and see what else has gone on. But for now, thank you very much indeed. Thank you.
Thanks for having me.